You may be asking yourself, what is momentum? Momentum is a combination of inertia and velocity. Momentum is not only a vector, but it's inertia in motion. As you can see by the car rolling down the ramp, it starts with no momentum at all, but builds up faster and faster as it goes down the ramp.
You may be asking yourself, what is impulse? Impulse is a change in momentum. It is caused by force acting over a period of time. As you can see, when I hit this baseball, the force I'm using with the bat to hit the ball shows impulse. It goes further and further by the amount of force I used to hit the ball. As you can see, the ball is crushed onto the softball field. Forces are usually what cause momentum to change. During a collision, the first law of inertia says that if two objects were to collide, their momentum is changed by the fact that when they hit, they will go in opposite directions.
As you can see during a collision, when both of these balls impact, they're going to go in opposite directions. The impact between both balls hitting each other makes them go in opposite directions. There are two types of collisions. There are inelastic and elastic collisions. Elastic collisions, objects rebound without lasting deformation. No object is done and no heat is generated. Inelastic collisions, objects collide and become deformed, damage is done, and objects possibly stick together and heat is generated. You see this hand right here? This isn't an ordinary hand. This is basically something that will stick to any object. But I'm going to show you a perfect example of inelastic collision by using this. By throwing this against an object, all of its energy is being transferred from this to the box. All the force that I'm putting on it is going straight to the box. And this is a perfect example of inelastic collision. If you saw that all the energy was transferred from this to the box. Obviously the box didn't move because its inertia is more than the hand. Newton's cradle is a perfect example of elastic collision. As you can see, each of the balls rebound without being deformed. No damage is done and no heat is generated. They're just going to keep going back and forth without being deformed, and no heat will generate. You may be asking yourself, what does the law of conservation of momentum mean? The law of conservation of momentum states that if there are no external forces, the total momentum of a system is conserved. See, I bet you're still trying to think, like, what does that mean? I don't understand, but it means that if there's nothing happening, nothing outside happening to whatever's going on, the total momentum of that system, that reaction, nothing's going to change. It's going to be conserved. You can try and say that momentum isn't conserved, like you think that it's all gone, like momentum isn't there. But really, momentum is always there. Like, no matter what, momentum is 100% always going to be there. You could think during, like, a car accident, if two cars are going to collide and hit each other, that all the momentum isn't conserved, like it's all gone. But really, there was none to begin with, and then once they hit, that's when the momentum stayed. Like, it's always going to be there no matter what. No matter what you think, it's always going to be there. I bet while watching this video, you think, oh my god, momentum isn't conserved at all. Like, what's going on here? But really, momentum is always conserved. When two objects collide, like two cars going for each other and they hit each other, you think that all the momentum's gone. There's no momentum there. But to start with, there was no momentum at all. In every situation, there's going to be 100% momentum. The momentum never changes.